In this set of videos, we're going to be investigating how to transform non-parent functions. Let's remind ourselves what a parent function is. A parent function is basically the simplest function in a family of functions. So non-parent function obviously is anything that's not that. Let's start this topic with an example. So let's do example 1. So say, for example, I have some function that I'm going to call f of x, and it's going to be a non-parent function, and we're going to transform it. So in this case, I'm going to say it's 2, I'm going to say it's 15 minus 3x, and I'm going to put a nice square root around that 15 minus 3x, and it's plus 1. So this is the non-parent function that I'm going to transform, and I'm going to transform it to g of x, all right? So it's from f of x to g of x, and I'm going to list the transformations that I'm going to use to do that. So the transformations are, it's going to be a reflection across the x-axis, and then I'm going to say it's a stretch in the y direction by a factor of 2. Okay. Then I'm going to say it's a stretch in the x direction by, by a factor of 3. And then finally, I'm going to translate by 2 to the left, so that's negative 2 there, and 5 up. And the question that I have for you is this: find an expression for g of x. In other words, find g of x in terms of f of x, or no, find g of x as like a final square root function. What is the exact numbers in square root notation? All right. So how do we do this? So what I'm going to do is, first, before I even start the problem, I want to state a few things. So when we say a stretch in the y direction by 2, remember that in functional notation, right? In functional notation, what this means is it's like saying 2 times f of x. So it's 2 times f of x. And if I say a stretch in the x direction by 1/3, this means f of 1/3 x. All right. Now, these two things, they'll become very important to us later, but for now, it's something just to keep in mind. All right. So let's start this problem. So let's start with here. So I have f of x is equal to 2, and then I'm going to put 15 minus 3x square root plus 1. And what I'm going to do is we're going to solve this problem using a visual approach. So the first thing I want to do is I want to factor it and kind of see how it looks like as a function or on a graph. So it's going to be 2. I'm going to factor out the negative 3, and that's going to be x minus 5, and then put a square root around it, and then plus 1. All right. So that's what it looks like. And so what it tells me is from the parent function of the square root of x, we have a vertical stretch by a factor of 2, or a stretch in the y direction by a factor of 2, a stretch in the x direction by a factor of 1/3. There's a reflection in the y-axis, and then translation 5 to the right and 1 up. So anyways, let's just sort of draw a rough sketch of this, and we're going to apply transformations to this function. So let me just pull that up a bit. So let's do this. I need a line. There we go, a line. Let's do that. Oops. So here are my axes. All right, here are my axes. So so basically what you can see is, I'll draw this with yellow first. So I can see that this is 5. Oops, that's a little too far. So let's do 5 over here. So 5, and then 1 here, and then 1 here, And since I can see that there's, like, remember, if I'm just drawing a rough sketch, it doesn't really matter what the stretches are. And I can see that there's a reflection of the y-axis. So originally it'll go there. So since there's a stretch, it would go there. So this is my f of x. All right, so what I'm going to do is step by step apply transformations to this. So by the way, if you're doing this, if you're taking notes right now, I highly suggest use a pencil. So because we're going to be doing a lot of erasing and seeing how this non-parent function transforms. So anyways, here we are 5-1, it's in that direction. So the first transformation that we're going to do is a reflection across the x-axis. All right, so it's a reflection across the x-axis. So if I reflect this function across this axis, this point will then flip over here. And then the arrow, so in other words, imagine if this is a mirror right here, it would basically look like that. All right? And so in other words, this 5 stays as is, but then the y-coordinate right here would be -1. And what I'm going to do now is I'm going to erase the old function because I just basically want to show step by step of where I'm going to end up. So I've done the very first one. Which is a reflection across the x-axis. Next, I'm going to stretch in the y direction by a factor of 2. Now, we'll get to this green part that I wrote here later, but first, I'm going to stretch in the y direction by a factor of 2. So if I stretch in the y direction by a factor of 2, it means it only affects the y's. So this -1, if I multiply that by 2, will become -2. So I'm going to go into yellow again. So in other words, this will become like that. And it stretches by -2, so this becomes -2, and there we go. So basically all I did was I stretched the y's by -2, but the x's remain intact. And what I'm going to do is I'm going to erase the old one. So there we go. Just going to erase the blue. And I'm going to rewrite that -2 right there. All right, so that's the new line right there. And basically I've taken care of that. Now, I have to stretch in the x direction by a factor of 3. That means all my x's get multiplied by 3. So all my x's get multiplied by 3. So therefore, this 5 will now become 15. So that should be somewhere around here. So that's 15. But the y's stay intact. So it's like that. And basically, everything gets stretched. And so then I'm going to erase the old one. Okay, I'm going to erase the 5 over here. So now we are at 15, -2. And let's go back here. So I've taken care of the stretch. And finally, we're going to translate left 2 and 5 up. So if I'm going to stretch left 2, my new point is going to become 13, because that's the left. And if I go 5 up, so from -2 plus 5, that's going to be +3. So let's just say 3 is over there. 3 is over here. And so this is my new starting point. And it's simply going to go like that. And then I'm going to erase the old one. And there you have it. I'm almost done. So this is finally, after I've done all the transformations, this is what my final function is going to look like. But that's not what the question asked for. The question asked for, find an expression for g of x. So we have to now find an expression for g of x. So in order to do that, what I'm going to do is I'm actually going to write f of x right on top. So here's f of x. Okay, here's f of x is equal to 2, -3, x minus 5 plus 1. And this is obviously, if we're looking for g of x, this is clearly our g of x right here. This is our g of x right here. So we're going to go to g of x, right? The thing is, what we don't know is we don't know, or let me talk about what we do know. What we do know is for g of x, our starting point is 13 and 3. So what's going to be here is going to be x minus 13, and then it's going to be plus 3. What we don't know are these numbers right here. We don't know what this number will be, and we don't know what that number will be. Because the reason why we don't know is because that's dependent on what f of x was originally. Remember, we're taking our non-parent function f of x and transforming it to g of x. So what we need to do is fill out these two numbers based on the information that we have. So let's take a look at this. So now this is that green part where that sort of comes into play. So in functional notation, if I say a stretch in the y direction by 2, that means 2 times my original. So in other words, whatever is in front, I have to multiply that by 2. So in other words, this 2 right here, well, that was already automatic. This 2 needs to be multiplied. These 2 needs to be multiplied by 2. Now let's go back here, where I said a stretch in the x direction by 3. In functional notation, that means f times 1/3 x. So whatever was the number was there before, I have to multiply that by 1/3. So in other words, this -3 here needs to get multiplied by 1/3. And I forgot one thing, which I need to also take into consideration, was I totally forgot the reflection. The reflection means that's a reflection across the x-axis, which means it affects the y's. So since it affects the y's, I'm not simply going to multiply by -2. I'm going to erase that just a little bit. I'm going to actually multiply. I'm going to actually multiply it by -2 because of that reflection over the x-axis. So what's going to happen here is that g of x, this is going to be my final number, it'll be 2 times -2, which is obviously -4. And then what's going to go inside here is this -3 will be multiplied by 1/3. -3 times 1/3 is -1. So it's -1. And there we go. Now we have our g of x, which is -4 square root of -1, x minus 13 plus 3. So let me recap what I just did. Okay, so here we go. We had our original function, which is f of x is equal to whatever, and I transformed to g of x, and these are the steps. And the question said find an expression for g of x. The first thing you should do is take your f of x and factor it, and then draw a rough sketch of it. Okay? Once you draw a rough sketch of it, then using the transformations that we have here, step by step, and using a pencil, like I said before, draw the one before, and then keep transforming it till you finally end up with g. Once you end up with g, you know what the starting point is. So in this case, for example, it's 13 and 3. So you would simply write a square root, and you would leave the number in front of the square root blank, and the number in front of the inside bracket also blank. But you would fill out the bracket and what's inside, because that's our starting point. So we know it's x minus 13, and then it's plus 3. So the next thing we have to do is fill in these numbers. Now, based on functional notation, and based on the reflections and the stretches, you need to know what to multiply by. So be careful. Remember, when you have the y, it's just you don't do anything. You just take the same number and multiply in front of the x. But when you have a stretch in the x direction, say for example by 3, you have to do it inside the f, and you have to do the reciprocal. So once you have those numbers set and including the reflection, get your original function and then multiply them accordingly. So you have to also take into account the reflections. So that 2 got multiplied by -2, which gave me -4. That 3 got multiplied by 1/3, which gave me -1, and we're done. And now we have a nice, neat expression for g of x, and we're done. In the next video, I will show you one more example of this. See you then.